recording has begun. Just want to say a very special. Well, this is how do you always start? This is day 2, week 15 of our journey together. Our journey started yesterday. Um, and many persons thought it was the holiday, so they missed class. But we're definitely glad that you're here today. Um, and so yesterday we talked about circle theorem, and so circle theorem is one of the topics that, like I said yesterday, we haven't covered in its totality, and so I wanted to really look at that. And today we're gonna continue in our journey of circle theorem. I do not know if we are going to finish it today. When I say finish, I mean finish all the theorems. I doubt it though, but we can at least give it a good hit. I think hopefully, I'm hoping that by the end of this week, we would have all the theorems covered, so at least the ones that you need to know. So yesterday, um, we dealt with the first group.
Excuse me, Mr. Petit.
Uh-huh.
I have a question. You remember in your old YouTube videos when you used to ask if you ready or something like that?
If I ready?
No, it used to be like, I have a question. Are you ready or something like that?
Yeah.
I was watching you last night. So I think that was so cringy.
I know you had a good laugh.
Yes, because when you press play, you scream, but good afternoon or welcome back or something like that.
Yeah. That was that was a long time ago. Oh boy, are you ready? I remember that.
I love it.
Yeah, that's amazing. Yeah, just wanted to get the students ready, huh? Um, yeah, so let's continue. Um, so circle theorem. This is part 2 um of the journey. So we're gonna be continuing in our talk. All right, so we're not gonna do this. We're gonna start off with this slide. No, we don't want this. So yesterday, like we said before, yesterday we looked at 2 theorems. So we have looked at angle. We looked at the angle in a semicircle. That was yesterday. All right, and we said that if we have if we construct a diameter and if we put a triangle inside that semicircle, right, because the diameter would cut the circle into two equal halves, and then if we put a triangle inside this diameter, sorry, inside this part of the circle, then this particular portion, right, this particular angle really would be 90 degrees, and that's always the case. All right, and we said that the way how we describe that rule, we said that angles in a semicircle is 90 degrees, so it will always equal to 90 degrees, like we said. We also looked at the angles on the circumference and at the center, and I don't know if anyone can remember the relationship between the angle at the center and the angle at the circumference. Anyone remember?
Well, like straight down the middle.
No. There's a relationship between the angle at the center and the angle at the edge, or angle at the circumference. Remember?
Equal.
They're not equal. That's important. They're not equal.
We're writing this.
They're not equal. From yesterday, we learned that before I give it away, anyone want to try? They're not equal. There's a relationship between them.
Well, less than 90.
No. Did you watch the YouTube? Did you watch the video from yesterday?
I didn't watch the whole thing.
Oh, you didn't watch the whole thing. Okay, so you probably might not know. So yesterday we learned that for this one is the one at the center, this one is the one at the edge, and this angle is twice what this one is. In other words, if this angle is, say, 30, right, this angle would be 15. And if this angle is, like, say, 20, this angle would be 10. And if this angle is, say, 50, what would this angle be?
25.
25. And if this angle is 100, then what would this angle be?
50.
50, right? So that's the relationship right there. All right, so the first one is that angles in a semicircle add up to um, add up to sorry, angles in a semicircle. The angle in a semicircle is 90 degrees. And the second one says that the angle at the center is twice the angle at the edge, or the angle at the edge is half the angle at the center. Okay, so that's what we looked at yesterday. Okay, so that's just yesterday stuff. Now today we will learn about another rule that could be used. Using finish?
No, sir.
No, okay. I think someone was asking to join. Let me see. Okay, no. All right, so that's okay, good. Let me know when I can move it.
I was I done.
You good? Okay, good. Let me allow this person to come in. All right. For those who are just joining, make sure please here are present in the WhatsApp chat. Okay, now today we will learn another rule that can be used. All right. And the rule says that, sorry, we will look at the problems that use it. Sorry, we will look at problems that use it alongside the rules we already know. So that's how we are going to be operating. So we will not only introduce this rule, right, but we'll also look at problems that help us to apply this rule, and not only help us to apply this rule, but help us to apply this rule alongside what we already know. So we're going to use this rule, this third one, learn it, understand it, and then also combine it with the other two rules that we learned yesterday. All right, so that's important.
What'd you say?
I'm saying we're going to use this rule and then apply it alongside the other two rules we learned yesterday. And so the rule says that angles in the same segment are equal. All right, angles in the same segment are equal. That's the rule. So let me know when
This is what they want in the second and third bullet point.
Yes.
You just make this PowerPoint up, or you had it labeled?
I mean, well, he's wondering why I haven't done this topic yet.
No, I say If like you just come up with this to teach the topic, or you had this thing.
I trying to figure out the true question. You want to know, like, um, what
Like
type?
you had this PowerPoint a long time, or you just make it
No,
like
I have
to
it.
do this.
I have this long, had a long time. That's why I didn't do it yet. That's why I haven't. That's why I didn't do the topic yet. Cause I quite frankly I didn't even remember them. So I had to review them first. Um,
Go back, please.
go back. I have to go back. Okay. All right. We learned that. Good. Yeah. Angles in the same segment are equal.
Yeah.
All right. Let me know when I can move it, please.
I done. I done.
Okay. That's good. Someone is asking to join. Okay. All right. So let's go. So this is the rule applied. So here we have um here we have these two angles, right? So we have this angle and we have this angle. And I want you to understand, right, that these two angles are subtended by the same arc. And so let me show you what I mean by that. So um let's focus on this angle. Let's call this angle right here. Let's call this A, right? And if you look carefully, right, this angle is like, I want you to think about it almost like a string is holding it. So let's say that this is a string, right? Let's say that this thing in red is a string, right? And let's say that you holding this angle by this string, all right? So this is the red string, and look at this angle. You can see let me color this one in, and I'm gonna use red to do that. But let's say that this is um the part of the string, like this is the wooden portion of the tool that you have. But let's say that this tool that you have, it's holding it by the string, and it's a red string, right? We call that string. We call that string. We call this string, this red string. We call it an arc. All right, call it an arc. So imagine with me, if you must, that you have this angle, right? This angle here, all right, and this angle is held, right? We hold in this angle using this wooden portion, right? Or you call it a steel portion, right? But we say that this angle, right, is subtended, right? Or in my words, is put together, right? Or is held together, or we could hold the structure using this arc, this red arc, right? And so we say that this angle A, right, is subtended by this red string, right? Or almost like a slingshot, right? We could hold it, we could hold this angle um, upward using this arc. Um, so basically, if you could think of your arm holding your whole arm on, holding the string here, that's the idea of subtended. It's like a holding or a pulling back, right? And so we say that angle A is subtended by this arc, right? So this angle B. You understand what I mean when I say that? Like,
I mean, I try to understand what you're trying to
I
say.
try to understand.
I ain't understand it though.
okay. Um, like if you have like the best idea I could think of is say um and I think it's my wording that I'm choosing. The idea that I want to get you, like, say a picture frame on the wall, right? Okay, let's see. If you have a picture on frame on the wall, not picture on the wall, picture frame. hanging on the wall. All right, good. You see that this is the idea that I'm trying to get. You see that? You see how this string holds this structure together?
Yeah.
Like it's holding it.
So,
Right? That's the idea that I want to give you with when we say subtended, right? This we would say that this frame is subtended by this nail, if we would use that like that. If you use that analogy, right? It basically holds it. You know what I mean? And so when we go to this arc, sorry, let me go back to
so all the sides could be like that.
no, I can tell you right now. So so you see that um this red string um is what holds this angle, right, on the wall, if you must, right? If we were to use that analogy, if this was a picture frame and we had it upside down, this red part is going to be the part that we would put on the nail. You know what I mean? To hold the structure together. You see what I'm saying?
Yeah, I get that part.
Right? So
So,
angle A is what sorry, angle A is subtended by this arc. And again, the idea of subtended is basically, that which we could use to hang it on the wall. If we had an imaginary wall, we wouldn't put it on this side. We would put it on this side. This is the part of the string. This is the part where the string would be, right? The red. Now, that's angle A. Now, angle B, let's use a different color, say green. Let's say angle B is the green one, right? Angle B is the green one. And sorry, one moment. So angle B is the green one. And let's say that again we have this wooden structure, right? Right out, right? And so you have this wooden piece. And if you look carefully, right, what arc subtends this angle, right? What arc does that? Um, I'm gonna draw green, right? So we would
is that
say,
the same arc?
say it again.
Are they in the same arc?
Ah, very good, very good. So we see that, excuse me, the arc that subtends angle A is the same arc that subtends angle what?
B?
Angle B, right? So that's what we mean when we say they in the same segment, all right? We mean that the same arc that subtends one angle is the same arc that subtends the other angle. You know what I'm saying? And so that's the idea, right? And they call it the bow tie rule because I don't know if you could see the bow tie it forms. You can see the bow tie, right?
Look at everybody.
Yeah. But the same arc so the red arc subtends angle A, right? And then the green arc subtends angle B. You see what I'm saying? And when we say subtends again, we mean like to hold, right? To suspend in midair, if we were to use that analogy, and comparing it to a picture frame. And let me just give you the exact definition of subtends.
So I have a question.
Go ahead.
Like how you saying it? Well, it holding like you use the example holding it on. Like you only can use like the bottom side. You can't use a different
You
side.
could use a different side as well. So subtend at a particular point when straight lines form, its extremities are joined at a point. This is the word. This is a good word. Extend under. So what? No, now I want to talk about subtend and what it means to take up the side opposite an arc, or sorry, to take up the side opposite an arc, or sorry, to take up the side opposite an angle or arc. Another word for subtend is subtend. No, I'm really looking for. Okay, basically the idea that I'm trying to get at is that, sorry, the idea that I'm trying to get at is both of these angles here, they have a connection with the same arc, right? That's the idea that I'm
Okay,
trying.
could you say they're identical? Almost?
What you mean the angles?
Yeah.
That's exactly what the rule is. So once they share the same arc, right? Once the same arc pulls it, once the same arc subtends it, then we say that the angles are equal. So A and B would be equal to each other. That's the rule. So A is equal to B.
Even though like B a little bit wider. I mean A a little bit wider.
No. They actually the same length. Just based on how I draw it, it looks wider, but they actually the same length.
Oh.
Yeah, all right. So that's the thing. When they say angles in the same segment are equal, right? The same segment in this scenario basically means that they share the same arc, right? The same arc subtends them. All right. So A has an association with this arc, and B has an association with the same arc. The same arc subtends both of these angles, and so we say that they are the same segment and then they are equal. All right. Let me move that. All right. So someone is asking to join. All right. Welcome, Lionel and what's the name? Lionel and Jonathan. All right. Okay. So if this is 34, right? Then what must this be?
34, right?
Um. Now I want you all to look at these two. Are these angles? Are they in the same segment?
Yeah.
No. Okay. Well, let's look at it. It does the same arc subtend then. So let's look at it. If we look at this angle, right? And if we look at this angle, I mean, sorry, if we look at this side of the angle and this side of the angle, let's look at this arc. The green arc is the one that subtends it, right? Now let's look at, as we can do this one in red, right? This arc, sorry, this I going now I going up down the wrong road. This side, right, along with this side, right, they're subtended by, sorry, this angle right there, this red angle, is subtended by which arc?
The green one?
The same green one, right?
Yes, sir.
So are they in the same segment?
Yes, sir.
Yes. So if this is 12 degrees, what would this be?
12.
12.
12.
Yeah, 12. That's the theorem. Okay? Angles in the same segment are equal. Okay, this is the minor segment, and this one would be the major segment. All right, so let's look at another one. So if this one, so we have these two, and now those two. These two would be in the same segment, so they are what? Equal. So if this one is 23, this one is 23. If this is 51, this one is also 51. Okay, so that's
Draw that one too.
yeah, draw that one too. And the third and final one is this one. Which two are equal? Which two?
The two what holding on by the little small arc in the corner. The small
These two? You mean these
yes,
two?
sir.
Yeah, right there.
These two, okay. And how about these two?
Yes, sir.
Yeah, they are equal. So that's the rule. So if this is 65, this must be 65, and this is 21, this must also be 20. And so that's the rule. angles in the same segment are equal. Or we say um, angles that are subtended by the same arc are equal. Oh, sorry. Wow.
Okay.
All right. All right.
I'm done.
No problem.
Hold on.
No problem. Let me I just put it back together. All right. So this is the second. This is the third theorem that we're on. Remember, yesterday we talked about angles in angle in a semicircle and then angle in at the edge and in the center. Today we're looking at this third one, which says that the angle in the same segment are equal.
Elizabeth, you know how much theorems are there?
There is probably like say, I know we in the third one. I think it's like, it's probably like 7 or 8. I can't remember off the bat.
Okay.
Let me know. Let me know if you're done.
Okay, I'm a little confused with the third one.
Okay, you're a little confused with the third one. Okay, go ahead. What's your question?
With the 21, how the two 21s get equal? I didn't understand that.
Okay. Well, if you look carefully, right? Remember the theorem says that the angles that are subtended by the same arc are equal. So let's look at it. So if we look at this angle, so this is the red one, and we notice the screen that subtends them is this, or the arc that subtends them would be the red arc, right? So the arc that subtends this angle 21, is the red arc. And so let me just show you. Notice that this 21 hangs on the shoulders, if you must, of this arc. It's connected to this particular arc. Would you agree? Hey, Kennedy?
Repeat that one more time, please.
Would you agree that this 21 degrees is connected with this red arc? Right? That's where it finds this association with this same arc.
I guess, yeah.
Okay. Now, let's look at the other 21. Excuse me. Look at it. So we're gonna carry it this way, and we're gonna carry it alongside this way. Sorry, let me make that clearer. Okay. Now, look at what arc the green one is associated with. You see what arc subtends that other 21?
Yeah, so,
It's the same red arc. Would you agree?
yeah, so.
And so that's why they are in the same segment. Okay? They're in the same segment, and so angles in the same segment are equal. Okay, so that's the idea there.
Would it be the same if you do it the other way around, like the arch, like where the next 21 is?
The next one. You mean if we start with the green and then correspond with the red?
No, like the arc, like next to the.
Oh, you mean this one?
Yeah.
All right. Okay, let's look at it, right? So the problem with that one is that we cannot say that, look at it, this this R on the outside is not for this 21 because notice it's in the back of it, right? When we say sub 10, we mean that, you know, the angle have to be in and then the arc have to be out. That's the idea. So if it's 21, the angle at sub 10 is 21 would be the one on the outside, not the one at the back of it.
Oh, all right. Thank you.
So that's the thing. So basically it's easy to recognize. Like you look at it as like a bow, like a necktie, right? Not a necktie, but a bow. So it's very easy. Like you'd identify your bow, right? And then the top ones are gonna be equal, and then the bottom ones are gonna be equal. That's the idea. It don't get out of it now.
That's what I was thinking too.
Yeah, that's the idea. Don't mind me with sub 10 and arc and all that stuff. That's just me.
Because when you was explaining it to Kennedy just now, I get confused with sub 10 and all of this stuff.
Yeah, I mean, it didn't really at sub 10. I mean, if you don't understand sub 10, that's how I understand it. It makes more sense to me later. But if you just thinking about it from just a pictorial standpoint, like just how it look, just identify a bow tie. And then the ones on the top of the bow tie are equal, and the ones at the bottom of the bow tie are equal. That's why it's called the bow tie rule. Math is easy, don't make it hard.
For you.
For everyone. What is 2 plus 2, 1?
4.
4, right? Did you wake up in the morning? Did you study that last night?
No.
Did you wake up in the morning being scared? Oh, I wonder if someone can ask me what is 2.2 plus 2.
No.
No, right? You just know it, right?
Yeah.
Exactly. That's how math is. All right, so let's use this rule, right? Look, clearly the bow tie. Like, I mean, if you can't see the bow tie, I don't know. All right, so what is 60 seconds? What is angle P, Q, and R? 60 seconds on the clock. Right?
P is 27, right?
No. Do it on your own. And then
Oh.
60 seconds. Let me start this timer.
This is you forget we got draw that way.
And the timer begins. Deep, 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 deep. 55 seconds left. What is angle P, angle R, and angle Q?
I ain't gonna cause me to scratch my head now.
Angle R.
Would it be P plus Q minus 180 gives you R?
You mean the other way around, right?
When you add them and you subtract it from 180, wouldn't it give you R?
Definitely. Yeah.
What she said?
I don't know. I have no clue. I have no idea.
Oh boy. When I remember she said.
I said, wouldn't it be
Nancy, remember, she ducked us yesterday. She was on the beach. She was on the beach, hot cross bun.
I didn't even know.
She was with a case of root beer, right? She was chilling yesterday, right? While we were slaving. Don't help her.
I didn't even go, but okay.
All right. So what is P? Angle P.
27.
27 because angles in the same segment. So like I say, the bow tie rule, right? Next up, angle Q. What is angle Q?
29.
29.
Yes, because angle in the same segment. Now R. How are we gonna get R?
I get 124.
124. Anyone else got 124?
I didn't calculate it, but I think I'm gonna. If she add them and subtract them from 180, I agree.
She had them from 180. What did you say? Miss what? You said what?
124.
Yeah, 124 is correct. Now the reason is um because angles in a triangle are equal, so they're supposed to add them. So you add them and subtract it from 180 because all these angles in this triangle are supposed to add up to 180 degrees. Okay, so it is 124. Angle R is 124.
You want to write us how you do it?
Yes, I mean if you already got it, that's fine. If you got it
Okay.
correct, that's okay. The only thing that you need to draw after that would be the diagram. Don't write this bracket. Don't put this bracket in front of you. Just write 180 minus 227 plus 29. But put the ones in red though. This bracket ain't supposed to be here. So 124 is the correct answer. Very easy stuff, right? Just bow tie rule and remembering angles in a triangle. All right, let's go. Can I move it?
Yes, sir.
All right, so let's do this. Calculate the angles W, X, Y, and Z from the information given. Remember that AD is the diameter of the circle. And so let's go. 60 seconds on the clock, and the timer has begun. W, X, Y, and Z. Remember, use all of the principles that we learned from yesterday and even today. All of them come into application, right?
I wasn't here yesterday.
Um,
Gonna learn today.
say it again, Kennedy.
Are you watching?
uh, 20 more seconds left.
I ain't even done drawing the shape yet.
Um, okay, so X would be 90
Okay, very good. X would be 90. Y.
because it's touching the perimeter, and then it is you could tell because it has a diameter, so automatically it'll be 90. C is also 90
Y is okay. So X is 90. Very good point. The reason why X is 90 because of the theorem we said that angle in a semicircle is 90 degrees. So if this is the diameter, we know this is a semicircle. This part of the semicircle. So the angle that is here would also will be the angle of is 90 degrees.
90.
Now, why is would you say is this is 90 again?
No, I said C is 90
Why is C 90?
because it touches the premise also.
Okay, very good. That's also true with the same one angle, the angle in the semicircle is 90 degrees, correct?
And the bow tie, right? I mean,
No,
thing.
no, this is it yeah, because of the bow tie rule too. Because of the bow tie rule.
Um, and then what I did after that is that I would add 90 and 15 to give me the corner of the corner, the remaining corner.
Okay, so all right, that makes sense. Add 90 and 15 to give you this.
Yeah.
What would
How
that be?
is
Go ahead, go ahead, info.
how y'all get 90 for well y'all say the touching the what?
Okay, that's from yesterday. Let me just show you. Miss the class and then don't watch the video.
Oh my gosh.
Now you still understand. Now we have to go all the way back, all the way,
I only
all.
asked
You have to go
I just
all the
asked.
way back. You have to go all the way back in this this
I
PowerPoint.
didn't hear what y'all say. I only asked what y'all say. That's it.
No, no. Okay, this is the idea. So if you have a if you have a circle, you cut it in half, construct a triangle in there. This side is always going to be 90 degrees. Same thing. This side will be 90 degrees. And then the same thing again. Which one is going to be 90, Miss Cooper?
Huh?
Ah,
Okay, that corner right there.
this corner?
No, the one above.
Exactly, the one above. Okay. So that's the idea. And then if we do another one on this side, which one's going to be 90?
You got the corner.
Exactly. The one is it's always the one that's directly opposite the diameter. Okay, so that's the rule. So that's how we know that for this one, that's how we know that for this one is 90 degrees. Because as you can see, here's the line, that's the diameter, and right here is 90. Okay, and then the same thing here. Like that's the triangle, and then right here is 90. So that's the idea right there. Okay, now we know this is 90, we know this is 15, so what must this be? This one.
You would add 90? No. And
No,
then minus it
we
from
need the
180.
we need to minus it
That
from
would be
180. So what would that be?
50. I mean, sorry, say 105. So 105 minus 180 would be 85, I think. I'm using a calculator because if you, no,
75.
no, 75, right? 75, sorry, 75.
75, yeah, 75.
Yeah,
75.
70.
So this is 75. The reason why we got 75 is because um this is 90, this is 15, this is 75. All of them should add up to 180. So that's how we got the 75. Now, what else can we get with that idea?
Automatically, would Y be 75?
Yes, why?
Um, that's my, because I think it's a what's the thing called? The E word you keep repeating when we have questions like these, how both sides are equal.
No, it's something we
When
learned a
they
long time ago. It started with
Well,
corresponding angles, that's what you mean?
not corresponding angles,
vertically opposite.
vertically opposite.
Oh,
Vertically opposite, yeah.
I just know it's gonna be.
When I look at that, I thought that wouldn't apply to these things. I was like, nah, that
Yeah,
can't
all
be.
them principles apply. I don't mind them. So if this is 75, this is
Seven.
75. Because vertically opposite angles are equal. And remember when we said with vertically opposite angles, are stuff like this. So this angle
So,
along with this angle. So if this is A, this must also be A. And if this is B, this must also be vertically opposite angles are okay.
And W, you would add 90 plus
Why you skip
75.
Z? I think Z is straightforward.
You think what?
Z. Why you skip Z?
Oh, Z would be when you add 75 and 75, and then you minus it from minus it from 360, and then you divide it by 2, and that's how you get Z.
Why you do the complicated way? You ain't seeing something that's fundamental. Look.
I think that way is better for me to understand.
Angles on a straight line at a point.
Yeah, you could minus that. You could minus 180 from 75, but I prefer to do it the other way because that's something I could remember compared to that
No,
one.
do it the other way because that's very true. You could have get it from the break. You didn't have. What if you didn't have this being vertically opposite, right?
What you mean?
What if you didn't have these two being the same thing? Like, what if this was just a little bit bigger? How you just gonna figure what Z is?
I was going to do Z pattern thingy.
How you gonna figure out Z?
Usually when they have the Z on the triangle, you could still, and never mind, sorry.
Yeah, you need to recognize that um these two are on a straight line, right? And they must add up to 180. So that's a fundamental. I thought you'd mention that a long time. But that's the truth. So 75 and Z is 180. So better than mine. So Z is going to be equal to 180 minus 75. Because angles on a straight line at a point add up to 180.
Mm-hmm.
So what Z is? What is Z? Z is
5.
105. Yes.
5.
Activity.
Yes, ma'am.
I'm sorry, but can you explain how you get Z again?
All right. Okay. Z, we look carefully at Z, right? Z is on the same line as, so this is C, and this is 75. So they on the same line. And angles on a straight line add up to 180 degrees. Okay, so 75 plus Z should give us 180. So that means that Z is going to be equal to 180 minus 75, which is equal to 105. That's how we got Z.
Oh, thank you.
I have an answer for W.
I have a question.
Go ahead.
You mean me?
Yeah, go ahead.
Why wouldn't you add an X75?
Okay, because you mean this?
Yeah.
Because that is not on the same side. So look, if we look back at this, right? So this is a straight line, and this is Z, and this is 75. Notice that they're on the same side of the line too. That's also the criteria. Right?
Okay.
So they have to be on the same side. Y is on this side. That wouldn't work. All right, so we can't do that. We have to stick to these two. Now,
Okay.
if we try to do it, we'll have to subtract it from 360, but we'll also need to know what this angle is, and we ain't going for that. So we're just considering the one side, and if we're using the one side, we have to use 180 degrees. That's why some people say, "Oh, boy, this child, man, he doing so good. He made a 360 turn." Now, does that make sense? Does that make sense? Boy,
No.
he made a
No.
360 turn, boy.
He's
Man,
a NASCAR driver.
hey, that don't make no sense because think about it. If you are here at this point, right? Right? Let's say you're at this point. And let's say, right? Okay, so the idea that they're trying to say is, the person went from being bad, good to bad, right? Bad to good. So let's say, right, this is your thing right now. So let's say that this is bad. This person is bad. This one is they're good now, right? You say, oh man, I don't know my child. Man, my child, he was so bad, man. Now he's so good. He made a 360 turn. Okay, let's see. So he made a 360 turn, right? So 360 means this all the way. You gotta go all the way now. Boom, that's 360 turn. If you make a 360 turn, you right back at the same spot. So your child did not make a 360 turn. Sorry, mom. Your child made not a 360 turn, but he made a 180 turn.
I'm glad I never had it.
Right? You never have people say that, eh? But it's right. He made a 180-degree turn, not a 360 turn. Right? So let's correct that. All right? Because think about it. If you, even when you walk in, right? If you walk in, right? And you make it, and you turn around in a full revolution, you will be facing the same direction again, because you turn around completely. So you're back at the same spot. But if you make a 180-degree turn, then you will, if you was facing north, then you will face south. If you was facing east, then you're gonna face west, right? But yeah, I just thought I would say that because I know someone who's always say that, and I say in my mind, I say one of these days I'm gonna tell this person it's not 360 degree, it's 180. But I
Embarrass them, yeah.
no, I'm not gonna embarrass him because I could have embarrassed him by saying no, I said that's not right. I need to. I
I was
want.
kidding.
I was gonna say it today, but I say, you know what? No, I'm gonna wait till a time when, you know, all is well, and I can tell them. Doesn't sound bad in public.
All is well. I was telling them right there.
I know you ain't got no leash. Um, good. So W, right? W, I think W.
It's 15, right?
Okay, W is. How you get 15?
Okay, the bow tie rule, and if you add
The bow tie
90,
rule.
70,
I think that. I think that's.
30 cut.
I think that's sufficient. You don't even have to do another rule. Bow tie rule is sufficient. Or if you add up all the angles, they should be equal to 180 degrees. So
And
that's
subtract it from 180.
yeah. So very good. I like that you identified the bow tie rule in this. 15. And just like that, we found all the angles. Look at that, right? So let's see how
180 no but one.
they do it. Uh, yeah. So that's how they did it. 75. Now, this is also a hint too. Usually, I can't say all the time, but usually when they have W, X, Y, Z, the way how they have it in terms of alphabetical order is the way how they want you to solve it. That's usually a hint too. Now that doesn't mean that it can't be solved another way, right? But that could be a way to get into the mind of the examiner, right? Like if they have W first, more than likely you're able to solve W without solving X. If they have Y before X, more than likely you can figure out what Y is before figuring out. So more than likely you can figure out what X is before figuring out Y. Now Z probably means that you need to figure out what W, X, and Y is before you get Z. Right? So that's how sometimes it is. Sometimes you could, play around with it and still get it, but the order can mean something. And so just note that. Right? How in the world is 7:05? How?
Wow.
Anyway, we have health in general today, right?
Yes, sir.
Mm-hmm. All right, send the notes so far what you have. I just want to see what you're doing. to make sure that we're on the same page. Send a note so far what you have. Okay, so we'll just light right up. All right, can I move this? Let me know if I can move it.
Yes, sir.
Right. All right, so find the missing angles. That's oh wait, skip. So someone is. Oh, I thought someone was trying to join. I guess that was the. Someone did join. Who that was? We just had.
Nobody doing.
Oh, the thing saying 19 now. It had 18 a few seconds ago.
That's plus you and the presentation.
Oh, okay.
Yeah, they just come the presentation or so.
They do. Having a class with myself.
Visibility, y'all spend your whole math lesson on this.
Yesterday?
Yeah.
Yes, sir.
Whole time. I figured, oh, I hate that. Oh my goodness. Sorry. See, no one. Can't do this. Can't deal with this today. All right, so let's go. 60 seconds on the line. What is E, D, C, B, and A? Hint, it might be smart to
I
go
know
in
what it is.
alphabetical order. It might be smart to go in alphabetical order. That's a hint. Okay, 1 sec. Sorry, not second. 1 minute.
We could start answering.
Time ticking.
All right. Are we good? Sorry, this thing. Yes, ma'am. Go ahead. Miss Cooper, you was asking something? I heard something when I left.
That was Nancy. She had to be start the question.
Yeah. Supposed to be finished by now.
Mhm.
All right, let's go. What help me with?
Yes.
Go ahead.
A.
Yeah. Five.
Go ahead. What is A? Let's try.
101.
How you get that?
I I I subtract it from 180.
Very
I
good.
subtract 79 from 180
180. Why would you subtract it from 180?
because that's angles on a straight line.
Yes. Wow. Very good, Miss Cooper. Wow. You're learning this in grade 8. You want to learn circle theorem? I learned circle theorem 11, 12. 180 minus 79. That is 101. So, all right.
Is B90?
B. He's saying B90. He's trying to make the case that B is 90. Do we agree with
No,
that B is 90?
no, I don't agree because 101 plus
Okay, I'm listening.
19 equals 120.
Very good.
120 minus 180 is 60. So B
Yeah.
could be 60.
So this is 101. Very good.
I got 60.
This is 101, and all the angles combined must be, um, go to 180. So it's gonna be 180 minus 101 plus 19. You see the problem, right? 1.
No,
You see why it's not 90?
not really.
Not really. Why would it be 90? Tell me why would it be 90? Like, what made you think it was 90? Go ahead. We don't bite.
No, I think I was looking at something else. I thought it was 90.
Okay. Yeah. But the reason why is that if you add up the angles inside it, it should give you 180. You understand that? A1?
B is 160, right?
B is what?
160.
Not 160. Can't be 160.
Oh,
Not 160. It's what?
60.
60.
Okay, I got all my answers.
It's gonna be
Mr. Busy, I am confused. There's two C's inside of this. That means the upper C and the lower C. We're solving the lower C, right?
Oh yeah, definitely the lower C, not the capital C.
Okay.
All right. In the same way, how capital A is not, in the same way we're not solving capital A, we're solving small a. The lowercase ones. So what is small c? You should know what small c is.
That's 60 degrees.
60 degrees. Why 60 degrees?
The both side
the
method.
bow tie method.
The bow tie rule. Boy, y'all like y'all bow tie rule, eh? Y'all didn't even saying the thing. Angles subtended by the same arc. Yeah,
That's subtended where it show me off.
y'all cut it right enough. Bow tie rule. That's it. That's all you know. Yes, it is the bow tie rule. Yes, sir. Bow tie rule right there. That means we could use. Gotta be careful. Yeah. So what is D?
19 degrees.
19. Yeah. Why?
Bow tie.
Bow tie method.
Bow tie method. Boy, you are liking it.
What the word is? Subtended?
Angles subtended by the same arc are equal. Always.
Yeah, no me remember that.
Yeah, angles subtended. Subtended.
Yeah, subtended. That's what I said. What did you say yesterday?
No, sir.
Did you watch the video?
I don't think I got a video.
I didn't send you a video from what? What's I supposed to do? So you understanding or it's confusion?
Oh, I got them all. Just E. E. Is that the semi thingy? Or that's
You
like
smart. You learn quickly.
E would be 90, right? 90 minus 19.
90. Why 90? Why you say that's 90? Yeah. What name is? Nancy, you're right. It is 90 because that's the angle in a
Is it
semicircle.
positive? Because I'm not positive.
Yeah, because look at that. Look at your triangle.
Oh, because yeah, that's what I based it off.
No. That can't be because it's in the semicircle. It's in the.
I get a different answer.
This is not the It's in the diameter. Let's see. No, we can't.
Come on, wait.
No,
We can't use
other half of the other. So would you have to fill in the blank next to B, right? So would that be 180 minus 60, and then you'll have to add. No, that would be difficult to do.
Can do 180 minus 19.
Say it again.
She did
She had
180
180
minus
180
minus.
minus what? 19?
19.
No, definitely.
I was thinking that because if you move out all of the extra stuff and you just pull out A, C, D, um, this A would be that'll be, because hold on, if you split that in half, because this is an angle, 180 minus 60 would give you the other half of A, or that'll be wrong.
180 minus 60.
No, I think so. I don't know.
Uh,
I think so because the angle it's without A, half of A, you get 180 on this one. So I figured it'll be the same thing for A, C, D.
I'm thinking.
I have an idea. The
Okay.
E
Okay.
this could be wrong. I had all the angles and minus by 80.
By what?
By 80. By
80.
180. Oh my god.
By
180.
Oh, I just missed something. You see where we have B and D, you see where the A is 101. Can we do the opposite thingy and put that in there?
A is what?
Okay, you see where A is, lowercase a?
Mm-hmm.
Can we put 101 on the opposite side?
Like vertically opposite.
Negatively opposite. Hmm.
Because I think it'll work. And
Give me
then,
an idea. You're saying for A is 101. And what else?
okay, to prove, I just wanted to understand, right? So if we put 101 on the opposite side of A, right? And then,
The opposite, yeah. That's true.
uh-huh. And then we got 60 and 19. So wouldn't ED, wait,
Help us. Go ahead, but let me finish it off.
because I was trying to do the opposite thing with C. Because if we do that, then we could automatically do the same the equilibrium thingy with CD. But I don't know. I guess I don't know.
Well, the thing about E is that E is what I'm thinking is that we have the triangle A, C, and D. For sure, we have the triangle, right? Um, we already know that it seems as if now they don't tell us. That's the thing. But if we knew that AD was the diameter, we could say that C was 90 degrees. We probably have to work on that assumption that the way how I am thinking before I actually look at the solutions. Um, maybe because the only thing we have that I can see here is
90.
that we have this triangle C A D. If we look at this triangle, maybe that'll give us insights into this angle here, right? I cannot see anything else whereby this is connected to anything else. Let's see. The only other triangle would be this other smaller one. But we do not know what this is.
Um,
We know this is 19, this is 19.
Reveal the answer.
um, hold on. This is 9. If this is 9, wouldn't that be like similar to a bow tie? No, no, I don't want to say that. This is not true.
I'd say I'd say AD is let's assume that that's the diameter. But that
Because
doesn't
it
seem
ain't
to
half of the circle, so can it be?
it's not half of the circle, so you can't use that rule.
I look confident on my 19 minus 19.
Mm-mm,
I don't know.
mm-mm. There's no
Okay.
there's no real reason why that happened. So let's look at that. So let's see. Um
Okay.
okay, C D. Everything they would like to see this E. Alternate angle.
What did it minus it from?
We're saying alternate angle, so E is alternate to some other angle.
It's alternate to 60?
It's alternate to one angle.
Yeah, it is alternate to 60 because of the both same thing. I mean, the switchable thingy. That's my only logic.
What do you mean by alternate angles?
Alternate angle, so this, so alternate would be
So it is Z.
Yeah.
It's a backwards one.
So you see the Z outline in red.
I was gonna ask what the arrows was for.
Oh, so 60 minus 60 minus, okay, so this is Z, right? And then if we come back, wow, that's nice. If we know that this angle right here is gonna be equal to this angle, so let me make a clear indication of that. So let's use a highlighter. This angle right here, this one, this angle 60 degrees is gonna be equal to this one here. All right, and so that means that we're going to have 60. So that means that E and 19 must add up to 60 degrees because them two are equal. So that's going to be 60 minus 19, which gives us the 41 that we need. All right, that's nice. So again, with these stuff, all the rules matter.
You could repeat what happened just now.
If I repeat what happened?
Wait, never mind. I see it.
You see it? Okay, good. Okay, we get it?
Yes, sir.
All right.
Not yet.
Okay.
I still can't figure out how we can think of that.
Boy. See, and that's one of the things, you don't just magically think of it, practice, and so now when you encounter another problem, guess what you're gonna do? You're gonna think about this rule. And so that's one thing. Persons ask, how do you know math? Da, 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 da. You don't just know it. You practice and practice, and such that your natural instinct would be to think about it.
Mr. D, from we see all these Z's, we should have think of that.
Why?
Because we got backwards too.
Does the arrows indicate the Z? Like the arrows?
It is trying to show you the tracing of the C, that's all.
Oh, okay.
Yeah. Trying to say this is the C here. Need no. In the Bgcse, they don't be this deep, though. I don't see them being. I haven't seen a question this involved. We should try one though. I don't know if we have all the tools yet. So we're not gonna try it until we have looked at all our theorems. So who wanna prove? Who wanna proof of the theorem?
Huh?
Proof of the theorem. We're gonna prove the theorem.
Okay.
The arc? No.
So basically, if you look carefully, right, this bow tie rule theorem is basically a derivative of the theorem that we saw before. So if you look at it, remember we said that angles at the center is twice the angle at the origin. So
The
angle at
corners.
the center is twice. Sorry, the angle at the edge is half the angle at the center, or the angle at the center is twice the angle at the edge. So if this is 2x, then we know that these ones are going to be x, and so that's how we get it. That's how we know that they're gonna be equal to each other. That's the proof.
Of the bow tie rule.
Mr. Petit,
Yes, sir.
you could go back, please.
So bow tie rule comes from the first rule. That's why we learned the first rule first. Because the first rule is, that's why we learned those two rules in the beginning, because this new rule actually is a derivative of the other of one of the other rules. Okay, let me know when I could change it.
Are you finished?
Alright, good. That's the proof. The next rule, I can't believe we only have, it's only 720. It's all the way 727. When we could finish the rest of these rules.
Are we writing this?
No, you don't need the proof. You need the proof. Alright. Theorem number.
These are exams?
Say it again.
Never mind.
Proofs are not in your exams. They don't ask you to prove them. All right. They only ask you to. I don't know if they ever ask you to prove them. In the GCSE, if you're taking the GCSE though, GCSE, that's Britain exam. If you're taking that, they'll ask you to prove it. The GCSE. They'll say prove this, prove that.
What about our own?
No, they don't ask you to prove it. No proof writing in the BJC or BGCSE. Sorry. All right, so so this theorem involves a cyclic quadrilateral. Now, a quadrilateral is a polygon that has how much sides?
Four.
Now, once we have a circle and we could put a quadrilateral inside the circle, then we call it a cyclic quadrilateral. Understand? So, for example, this is a quadrilateral, right?
Yes, sir.
1 side, 2 sides, 3 sides, 4 sides. Now let's throw a circle on it. Voila! It's called a cyclic quadrilateral. Just like that. You saw that? Let me do it again. Magic. This is a quadrilateral. The quadrilateral. 1, 2, 3, 4. 4 sides. Now once we put the circle on it, voila! Cyclic quadrilateral. Just like that. Okay, I know. The magic is killing me.
Mr. Petit, we writing that?
Yes, you're writing this notes. You know what? Just look at the screen. Just look at the screen and, just chill. You're then home. You're then in your own clothes. You're then in your own room. I mean, the least you could do is write that on the notes. Gee. Have mercy. All right. 4 sides. All right. Voila. Cyclic quadrilateral. And then the last one.
It's a bit today. You want to do it? I'm writing.
I ain't doing what?
I'm writing.
That much writing? Oh, you want me to write?
Like, no, like I used to be. You just clicking next. That's it.
I need to do more clicking.
Mr. You write yes?
What? If I develop this PowerPoint?
Yeah.
No, I make it. I found it online. I thought it was wonderful. Wonderfully put together.
That gotta be cap.
Say it again.
You for real or you just being a clown, Mister?
I did, serious. You didn't have the time to make all this. I don't know.
That's Bill Cosby.
Yes, that's Bill Cosby. That's one of the students' friend.
I told you can pass and I did that.
I know, right? God help us. All right. Opposite. So now that we know the definition of cyclic quadrilateral, now we could use the idea in our theorem. Okay, so theorem. This is the fourth theorem, eh? The fourth theorem that we are going over.
Yes.
And the fourth theorem says that opposite angles in a cyclic quadrilateral add up to 180 degrees. So what we mean is, which angles you think would be opposite? So
one across from each other.
yeah,
That one right there.
yeah. So
A and
Open,
C.
these two would be opposite, right? And
Oh.
What about the next ones?
Yeah, these two would also be opposite. So these opposite, so it has to be a cyclic quadrilateral. That means it has to be a quadrilateral inside a circle. And then if we have these angles in here, they're going to, if we add them up, they have to equal to 180 degrees. So if this is 85, what must the second side be?
85.
No. You have to add up the
What?
My you subtracting it from 180 to get the other side, eh?
which is
95, I think.
not 95.
No.
It can't be 95. Get your calculator now. Quickly. Get your calculator.
Wait, Mr. T, you mean the other blue or the red?
The other blue.
That's far, man. Hold on.
Get your calculator.
80 leaves you with 100. Then you minus 5. Isn't that 95? Or am I tripping? Didn't I say 95?
You did.
So why you say I was wrong?
You was guessing? All right. So they must add up to 180. Next up, if this is 88, what must the other side be?
180 minus 88.
92.
92.
That's a guess.
That's absolutely right. Good. So next up, if this is 30, what would this side be?
150.
150.
Very good. If this is 140, what would this side be?
40.
60.
40. Very good.
Oh, no, I did not just say 60.
I hope not. And finally, if this is 99, what would this side be?
10. Say it, oh, geez, say 10.
Get your calculator.
80, 81.
Very good, 81. If this is 77, what must the other side be?
These odd numbers, man.
Yeah, the odd numbers.
103.
103.
That was a
Yeah.
strong guess. Oh my. I need to work on my basic math, man. It's trash.
Yeah, basic man. That's what happens when they give you all the calculator too early. You know,
I agree.
that the BGCSE never used to allow calculator before.
Was calculated even
They add
in
letters,
nowadays?
right?
So what they would get longer timing.
Say it again. Yeah, I mean
Ian,
They would,
that was
these
before my
numbers.
time though. It was pure. It was pure. You guys have to know it.
Yeah, my dad said he did the GCSEs. He didn't do no BJC at that time.
What I mean is
Yeah.
there was no calculator usage.
No.
That's what they. During the time, you still saw letters inside numbers.
Of course. That's
Okay.
that's
I know it's a stupid question.
What do you mean by letters and numbers? What you be talking about?
Like letters and numbers together.
We have that? I don't be paying attention to no questions, man.
that's huge.
all right. So let's continue. Can I move it?
Yes, sir.
All right.
Mr. Petit?
Yes, ma'am.
Yes, sir.
Go ahead, Nan.
Do we have letters and numbers combined in an exam?
You mean like with the algebra and stuff like that?
You mean like when we can simplifying a
Yeah.
We got 4 more theorems to go.
Say it again.
We got 4 more theorems to go.
So you think?
Mr. You say 8.
I said probably. I can't remember.
Mr. Petito, I think I missed a theorem. I think
Let's see. What's the theorem you missed? So far we're on the fourth one.
I missed the bow tie.
The bow tie. Okay. The bow tie.
We come in like 7 o'clock.
The bow tie theorem says angles in the same segment.
I could just take screenshots of the notes so I can write it later.
So they always say.
Keep going, keep going.
They always say. Alright, we wait. Can I move it? Okay, sure.
Hold on, bring a picture of this one.
Sorry.
That's so rude, man.
Mr. Petit, that noise.
Jonathan,
Wait.
please stop foolishness.
That's Belko SBA.
Yeah, that's Jonathan.
Okay, you could go again. Keep going.
Okay.
Okay, I think I have everything. Like, could you go back one, please?
No.
Okay.
This? This?
No, I think I have that. All right, you could go back to that first. Thank you.
No problem. Jonathan, stop your foolishness, please.
Peace out.
Alright. Okay. All right, so that's the first rule involving the cyclic quadrilateral. We know that opposite angles in the cyclic quadrilateral add up to 180. Now, the next rule concerning cyclic quadrilateral is that an exterior angle in the cyclic quadrilateral will always be the same as the opposite interior angle. So an exterior angle in a cyclic quadrilateral will always be the same as the opposite interior angle. So let's break that down. So let's look at it. So which one will be the exterior? Exterior.
The outside.
The ones on the outside. So these are the ones on the outside.
Outside.
Yeah, exterior. Okay. So let's say that we know that this is 73. What would this be?
73.
So, oh, Dave, man. Not this one. The opposite one. So it have to be the opposite one. So this would be 73. Now let's look at this one.
You mean like low top, high bottom then?
Yeah, like that. 80, if this is 88, the opposite one would be
88.
So an exterior angle in a cyclic quadrilateral will always be the same as the opposite interior angle. Right, that's fair enough. If this is 73, this is 73. If it's 88, this is 88. So let's look at another one. If this is 104, which one would be 104?
The one down from it, bottom one,
You mean
across
this
from it.
one?
No,
No.
the next one.
This one then?
No.
Yes. No, to the bottom.
This?
Yes, sir.
Definitely 104. If we know that this is 107, what else would be 107?
The one opposite of that, to the bottom.
The bottom opposite.
Yeah, this one. 107.
This is the thing, we have to draw all the shapes, so you can just draw one of them.
You know, just look at the screen and stare at it.
We could draw one, or we have to draw all.
What's the point of even writing notes, right? All right, so if we know that, okay. All right, so if we know that this is 135, this is 86, this is 45, this is 94, what will be this? What will be that? Look at it carefully.
45.
Let's start off with this. What would this be?
45. What?
45? No, can't be 45.
No, 94.
94. Very good. What would this be?
86.
Can't be
86.
No, can't be 86.
45.
45.
Which one are you pointing to?
I'm pointing to this one. This can't be
45.
So that's 45.
45. Yeah, it have to be 45. Because remember, look at the idea. The idea is that it have to be opposite. So
You can turn the angle, like turn it to see.
you must be able to at least draw a line like that.
Okay, I see it now.
That's the idea. You must be able to do that.
But with 45, how you can draw that line though?
Right there.
But that's crooked. Like that ain't straight.
That's what I'm saying. No, that's a straight line.
I mean, this is what you mean in a straight line? What? I have to make it specific.
It's a straight. No, I'm saying it's a straight line. It isn't like how these ones is. The only time it makes it look like it is because when you cross 94 to 94.
The same thing. They literally the same thing. I don't know what.
Bad night, boss. Bad night.
They literally the same. This is literally like you literally can see the connection. Like I don't see the difference. Like you could clearly see this one. Okay. First of all, process of elimination. It can't be 86. 86 is too close. It can't be 135. Right? 135 is too close to that. It have to be either 45 or 94. 94 is much more opposite to that than this one. This one is too far. They're on the same line. They're on the same plane. So it can't be that. Right? If we look at 73, right, and this one of the major criteria is that number one, they can't be on the same plane as the other one. So this one ain't gonna cut it, right? 88 ain't gonna cut it. It must be on another plane, or sorry, on another line, and it must be opposite it, right? It's clearly it, right? And so we use the same logic. All right, this is 45. It can't be this, right? Sorry, and it cannot be the ones on the same line as it. So it can't be that. Right? So it must be this one.
So I could have been 135.
Why couldn't it have been 135? Because it's not that. Okay, let's look. 135 is inside. We're talking about exterior. 45 is outside. So we're looking at. We're talking
I
about
mean,
exterior and interior. That's how we look at it. One on the outside, one on the inside.
why the angle where we put 45 for the missing one, why that couldn't have been 135?
It can't be 135. How that could be 135? That'll be the right there. They on the same line. It can't be 135.
Oh. Right.
Mr. Potato, come up with circle theorem.
Let me just shoot him.
Person ain't had nothing to do.
This is you need to understand. Math is not necessarily a construction, but more so a discovery. All right, so just understand that. Like, if they did not discover this, it still was going to be true. Right? And so math is not something that someone made up per se. It's they discover it. So they look at they draw a circle and they see these patterns that exist within the circle. And so they just give them different names. Right? These patterns exist by design. This is how God created things. Right? And so we just give names to it. If you want to blame anyone for math, the first person to blame is God. He made it so. We just discovered what he. Yes, he did. The animal.
No, I mean, I can't blame God. No, sir.
What do you mean you can't blame him? He's the one who is responsible for math.
No,
So,
I can't go to God and say, God, you offend me by doing math.
Well,
That's like,
why you can blame Isaac Newton for saying, "Hey, this is how God made it. This how he made the circle."
these people, you say we can clash people, we can't clash God.
Exactly. So you just want to throw stones at the messenger. Don't throw stones at the messenger. It ain't his fault. He just telling you what it is. So how you can throw stones at the man who say 2 + 2 is 4? He just saying, listen, if you count your sheep, you have 2 sheep on one farm, 2 sheep on the next farm. Altogether, you have 4 sheep. Anyway. Alright.
You didn't have to count a sheep.
He didn't have to count a sheep, but how he can know how much sheep in a day?
That's what he might not know.
You know, he need to
This reminds me of Moses. Oh, wow. Oh.
He need to take his, we have 10 minutes left.
Oh no.
What the name is though?
Invite him in, Mr. Petit.
Let him in and
Star trauma, no.
You promise me to say that in this video. I only laugh. I ain't gonna say.
Kennedy will be the first to lash out. Kennedy ain't got no leash.
I is still humble and in the corner.
All right. Okay, so let's calculate this. Let's go with A. What is A?
A?
A.
6. No, never mind.
What A is gonna be?
A is 180.
A. How are we gonna get A? Tell me how we gonna get A.
180 minus 112.
180.
180 minus 112.
And then that would be like what? That's like what? 7? No, that's like 68. 60.
Yeah, 68.
68 or 168? Which one y'all saying?
68.
68 sounds more reasonable.
Very good. 68. Good.
All
right. Next up is B.
B would be
the same.
180 minus 68.
No, the same 68. Why? We saw this theorem before.
Correct. The opposite. Opposite.
Interior angles for cyclic quadrilateral are equal.
Yeah, opposite.
What is C?
C is 93. Is it?
Yeah, 93.
Will all that add up to 360?
Yes, ma'am.
Should it?
Mm-hmm.
Excluding
Excluding
112.
Yeah.
Okay. Let me see. I make 93
So we did do it right.
plus 68 plus 68.
Wait. Why they say C is 87? Opposite
Hold
angle.
on, go back.
Oh, no, it's not 87. Opposite angles add up to 180.
Mr. T, but 93 plus 93. Wait, you have one. Okay, never mind. You have 112 there.
Wait.
They subtracted, right?
Oh, we
The
wrong.
180.
It's not equal to 180. That's our fault. The rule
Thank
says
you. Thank you.
Because I was getting confused.
the rule says not that they are equal. The rule says that they add up to 180. See, I knew that, I just was testing you on.
Why I didn't.
And I just vacuum my pre-work calculator to make it make sense. Wow.
Yeah, that's my bad. The rule didn't say that they are equal. The rule said that they add up to 180. So this one is
I just put it through. I don't understand.
180.
I was wrong again.
All right, you can't.
Kennedy, that's how I felt yesterday. Don't worry. Yeah.
That's how you feel every class. Defeated. 112, 68.
What's going on here?
And then at the end.
Insulting, I tell you.
Oh, you'll be all right. By the time you finish this class, you'll be able to take on the world. All right. All right. So this is So these supposed to add up to 180 degrees. So 180 minus 68. Right? It's gonna be equal to 112. And then similarly, 93 and C. So C is going to be equal to 180 minus 93. Is equal to 87. All right, so.
What did we get wrong, Mr. Petit?
Oh, we said that they were equal. They're not equal. They add up to 180.
So we were supposed to be minus.
Yeah, we're supposed to minus it from 180.
Hello? Mr. Petit?
Present. I'm here.
Oh.
Can't even
He's alive.
I can't even drink water in this glass. Mr. Petit, where is he?
Yeah.
All I need is 5 second rule. The 5 second rule. If you ain't Mr. Petit 5 seconds, all right, that means peace out.
It's a titty and sleep, and I can see it on here.
All right, so let's go.
1 minute, please. 1 minute.
Okay. You say 1 second, no problem. 1.
1 minute. Mr. Petit, I'm to graduate from this. You keep doing this to me. I'm left this in the past.
You're right. That's true. We're new people. You're right. You're right.
Clearly, you're still the same.
Yeah.
And new people. Alright. Fly straight. That's twice. Good.
Hold on, I finished it. Hold on.
Still writing?
You said there's a lot of notes now.
Just small things, man.
Really.
Um,
Languages be a lot of notes.
language? Oh yeah,
You
language.
said my hand tingling in language.
Yeah. Language is easy after that. Missed you, Miss Cooper.
Why
Okay.
did
I
you
think a lot of
today? Is
Say
it?
it again.
You want mean Friday or Sunday?
I think of
Say it
words.
again.
You want mean Friday or Sunday?
Um,
Y'all keep saying yesterday.
yesterday was Monday.
Oh, I thought today was Monday.
Good.
Oh wow.
Wow. But today I wrote on the board Monday, and the thing is like, Mr. Petit, today is Tuesday.
My class do that all day. They keep saying we don't have this. I say, y'all, it's Tuesday. It's not Monday.
They felt like Monday. I ain't gonna lie, to be honest.
Yesterday still was holiday.
Yeah. No, yesterday was not holiday, my dear. Yesterday was
It
class
was beach
time.
day.
It was a holiday.
No
It was a
holiday.
holiday.
It's class time.
It was a holiday.
See, that's what
It was a holiday. It was beach day.
See, that's how I know. All right.
But I ain't that kick the beach. I ain't
Yeah,
that kick
right.
last.
Yeah. You have to put the disclaimer. We saw you on TikTok.
Not I.
Boy,
Work out angles P and Q. Explain how you got the angles. 0 is the center of the circle, and ABCD is the side of the quadrilateral. All right, so let's do this.
Okay, so
Why did I give you this test? It's too easy.
would
Sorry, go ahead.
would the Q be half of 102?
Yeah, I believe so. Mm-hmm.
And then we would minus after we get Q, we would go back to O, and then we'll minus 102 from 360, and then we have them until we get to get P.
Yeah, that's true.
The reason being is because basically what you tell me is that the perimeter is always half of the center.
Yes, there's an easier way to get P in it. If you know what Q is, you know that opposite angles in a cyclic quadrilateral is what? They add up.
180.
They add up to 180. So there's an easier way to get P.
I just remembered the way you taught me. Like I ain't remember no other way. So you taught me this a couple days ago. So
you're right.
I ain't remember no other way.
All right, but they just trying. I guess they just trying to show you that there's different ways to skin the cat. So so P is going to be 51 because remember we said that if this is the angle at the center, the angle at the angle at the circumference is going to be half of it. So that's going to be 102 divided by.
Mr. Petit, what you say?
If you was here yesterday.
Oh my God.
He was on the beach. All right, what we're saying is that basically the idea is that this angle in the middle is twice the angle at the circumference.
I thought 0 in the center.
No, 0 is not no, that's not 0 degrees. This 0 means the origin.
Okay.
So the angle that's in the center is 102. Right? This means this is the point. This is not talking about angle. So it's not angle O. All right? It's the origin O, which is the point. So this is the angle that's in the center. The angle that's at the circumference is Q. And so this angle here is going to be half of 102.
We finding Q or P?
Wait. RG.
And you?
My apologies. This is P. It's supposed to be P.
I'm trying to figure why you at Q if you trying.
That's true. My apologies. Yes, you're right. It's supposed to be this way. This is the angle at the center, and then the angle at the circumference supposed to be 51. So that's it right there. So this is gonna be 51. This one. All right. Okay, so that's the case, and then so Q is going to be equal to. We know that if P, we know that P and Q are opposite. They're opposite angles of the cyclic quadrilateral. So Q is going to be equal to 129. We got 129 because of 180 minus 51.
What just happened?
All right. What I'm saying is, remember we said that if we have a quadrilateral,
You put 29 instead of 129.
thank you. If we have a quadrilateral, right? These two angles right there are going to be, they add up to 180 in the cyclic quadrilateral. So in a similar manner, we have Q and we have P. These two are opposite, and these two are opposite.
I was looking at the little small one, and plus the way I draw it in my bucket didn't look like.
Okay, so that's the thing. So Q and P are opposite, so that's how we're gonna get the 129.
It's after 8 o'clock, Mr. Petit.
So Q is 129.
Yes, sir. Q is 129. What that's supposed to mean, Nancy? You ready? You disown us like that?
Yeah. Time for bed.
Nancy, you disown us just like that?
No comment.
No comment. Yeah, thanks for the reminder. I didn't even realize it was after 8. All right, so we can't go without homework.
Petit,
Yes,
Did
sir.
you mark our
how long
homework?
this topic lasting?
How long this topic lasting? We have several more theorems to go to. So definitely tomorrow is again circle theorem, and then Thursday is again circle theorem. I'm hoping that we could finish circle theorem by Thursday. I'm hoping.
Next week Thursday or this Thursday?
This Thursday.
Oh,
When is Mr. Petit, when is the 3rd of May, by I want to ask?
The 3rd of May.
Yes, sir.
That's a Tuesday, the 3rd of May.
Because that's our first exam, paper 2,
Paper 2 of what?
English.
You mean the listing?
Uh-huh.
Okay. So, y'all need help with that?
That's what week after next?
That's week after next year.
Praying for y'all. Y'all can do well.
Need help?
I still looking for someone to set it for me, so we'll see. That's my biggest subject. I ain't gonna lie and say
You know,
I'm
going there
excited
thinking
to
about
take it.
Don't go in there thinking it's your weakest subject. Please don't adopt that mentality. The mind is a serious thing, you know. So don't go in there thinking like that. Go in there thinking that you're gonna crush it. How you gonna crush it? You don't know. But just go in there with the mindset that you're gonna do well.
Awesome. I get 50. So
Kennedy, please. We only want comments to increase confidence now, because and honestly and truly, people just get exam anxiety. All right, and what y'all need to do, y'all need to remember to never murum. All right.
Is it only me studying English, or is it a lot of people in the class?
I send it at me.
And one is in Pinches. Good.
And then English too.
And Alicia's sitting it too.
Oh, so I'm not alone in this.
Ricardo
All
is
right.
sitting it too. Who else is sitting it? You all for sure. I know one, Alicia,
Floyd.
Ricardo. Who else? Oh
What
yeah,
about Floyd?
and Floyd Bethel, yeah. Okay. All right, so I think we good. Yeah, okay, so that brings homework. Oh, Nancy asked about the homework thing. This is the answers for the homework. So let me just get that to you all. This is the answers for homework. So take a screenshot, and if you got it,
Okay, looks like I get some right. I look, yeah, I get a couple. That's impressive.
all right, that's what I'm talking about. I'm putting on the screen again.
I thought I was getting 3 out of 5 or something. No,
I
3
don't
out
even
of
know.
10.
This is the homework answers.
What the homework is about.
All right, watch recording. Watch recording.
I thought I was getting 3 out of 10, honestly. I thought I was getting the first 3 right, and that's it.
All right, that's good. Did you get
That's
all?
me. I got to check, but I honestly, when I was doing it, I thought I gave up a couple times, and I said, oh, let me just finish it. That's what matters. Finishing it.
Finishing it.
I just only getting 3 out of 10.
What else? There's something else. Oh, the homework.
Letterman,
Why you want?
he ain't gonna stop.
Why you want Bill Cosby to come in, guy?
Letterman, my favorite was with
Oh,
Did nobody know what
we
would
knew what
happen?
happened last time. We already knew what happened last time. Yeah. Let me give y'all this homework. Take a screenshot of it. Oh, just do. Yeah, take a screenshot of it. Do A through I. A through I. A through I. Please do the homework that is assigned. Right, Miss Kennedy? Right, Miss Cooper? Right, Miss Alicia Rackley?
It's
I also see
hard.
your homework.
Who said it's hard? Who said it's hard? Kennedy, you're a maths brain box. You know it's
Okay, good night.
I also do your homework.
all right. Yeah, right.
It's the last homework you get, I do it. So I need to jump in.
Do this one then. How about one?
What?
Also have to do?
Well, I'll be back then.
How do you know you going?
I have a.
All right, so we're gonna continue where we started. Yes, on the last class with general science. We was talking about the different characteristics of. We was talking about
An animal
This
of an organism.
excuse me.
yes,
This channel.
yes, generally, yeah. We was talking about the different features, right? We was talking about that we can divide the whole animal kingdom into how much groups? The whole animal kingdom can be divided into how much groups? We said
7.
broad groups. Into how much broad groups?
So, vertebrate and invertebrate.
I got 2 broad groups, vertebrate and invertebrate. And then we said that I show on the notes from last time. We said that there are how much classes of vertebrates? How much classes of vertebrates do we have?
33.
Not 33. Give me an example of a class of vertebrate.
Phylum.
What?
Sure, let me give you a good example. Fish.
Oh,
Oh, you mean like that?
Yeah, fish. What else?
Dog.
Mammals.
Fish, mammals.
Oh, what is wrong with me?
Fish, mammals. What else?
Bird.
Birds.
Starfish.
I don't want individual organisms. I want the class.
Sloths.
Mammals. I don't want individual animals. I want the class.
Amphibians.
Say it again.
Amphibians.
Amphibians and then
Arthropods.
arthropods.
I think that's how you pronounce it. I don't know. Arthropods.
No, I don't want arthropods.
Reptiles.
I heard it.
Reptile.
Reptiles. Very good. Good. All right. So that's us. So that's what we learned last class, and then we was discussing their various characterizations. So vertebrates, animal with a backbone, and we list off the criteria. We're talking about the fish, how their bodies is covered with scales. They live in water, cold-blooded. We gave some examples. Then amphibians, all this is last class stuff. So we left with amphibians. So we just did fish and amphibians. Wow, that's it. Okay, so we really need to do better. All right, so means we need to do more writing today. All right, let's finish this up. So reptiles. Please take down the notes, and then once you're done, please send it to me. All right, so reptiles. With reptiles, what do we know? Their body
Are hard and rough.
Cold-blooded.
Their body is covered with what?
Scales.
Dry scales, right? They breathe with what?
They're long. No.
Yeah,
Lungs.
right. They breathe.
Lungs.
What else we have? Do
They're cold-blooded.
Cold-blooded, I like that. Cold-blooded.
Yeah, they cold-blooded.
Cold-blooded.
They can live in land or water.
They can live.
Water.
What do they
Yeah,
live?
I was saying the same
I
thing.
didn't really say water.
What do they
Repeat
live
that.
in the end?
Repeat that.
Okay, they live. Like someone said it. They already said it before.
They live in
Land
and water.
Yeah. That's cool, eh? You can live on land and in water. My goodness, that's cool, man.
telling you.
Wish that was me. So
It's too hot for their cell live in the water.
That's crazy. You know this. That'll be so cool, man. Like you coming out the water, like
Real boy.
walk in the water.
That's perfect for summer.
I'm telling you.
Oh, yeah, they get it.
All right. But they lay their eggs mainly where?
Under the dirt.
In water?
No, deep in the dirt.
Oh, Lonnie.
Yeah,
Oh.
lay their eggs mainly. All right. Next up is
Excuse me, Mr. P.
yes, sir.
In your little days, did you used to watch PBS Kids?
PBS Kids?
Yeah.
Not that much, honestly, not that much.
Okay, do you remember like Wildcrafts?
No, I don't remember that.
Well,
okay.
All right, let's move on.
Who doesn't love Wildcrafts, bro?
They sit on eggs, right? Until what?
Hatch.
Until they hatch. Yeah.
Hatch, yeah.
Oh, so they're like, in a way, they like birds, I guess.
Yeah, in a way, yeah. Some feed and protect their young. All right. Give me some examples. Would be a typical example. We found it all the time in Nassau. All the time.
Yeah. Oh,
Girls are scared of these. Girls are afraid of these. With all their-
Snakes?
Not snakes.
But bugs?
Man, it's start with L. Start with L.
Lizards?
Lizards.
Those ones.
Scared of that. I mean, I am. Okay.
The little girls just be scared of roach. Anything with bugs.
They scared of lizard. They really do.
They can kill me.
I'm scared of
I
lizards.
have enough for myself.
I don't understand that.
They don't
People
make
scared of roads. The roads
Lizards don't do
the roads
nothing,
trying to
bro.
run away.
They don't do nothing, bro. They scared of you.
exactly.
They trying to run away from you, and you running
Next one
away
is
from them.
alligator.
Of course.
No, of course. Who will be scared?
Now you need
Of course, everyone's scared of alligator.
to be scared of that.
Let's get there. Something wrong with you.
Gotta be
Yeah,
scared.
alligator
How about
fighting.
turtle?
You step in front of an alligator,
It
dog eat your
depends on
lunch.
what type of turtle.
And
If
then
it's a stomping turtle, run.
Obviously
You want to see how they
one of the major ones is what?
Crocodile
Crocodile.
Crocodile.
and frogs. Right?
Crocodile.
No, frogs is not reptiles. Frogs comes under
Amphibian. Sorry.
amphibian.
Amphibians.
Yeah.
Remember that.
All right, so that's lizard. That's reptiles. Now let's consider birds. That's gonna be our next one. Wouldn't it be cool to fly though?
Of course.
Yeah.
That'd be cool.
You don't have to waste money to go on plane.
That's true.
It does.
But listen, you'll be tired.
Yeah, but
Never.
You'll be tired.
Well, not necessarily, because like the feathers can help you glide.
Yeah, that's
You know.
true. You know.
That's some arm strength, though. What?
That's true. That's a long trip. You gotta. That could take several days. I ride an airplane for long distances. But it depends.
why?
Yeah, wasting money there, Mr. Petit. Wasting money.
But if you like
Well, I'll fight you that to get to the next spot.
if you like an eagle, then you're really good. Like you can move fast. But if you
Yeah, I would be an eagle because
Yeah, eagle. is better.
it's not really that much than a regular like, pigeon.
All right, body's covered with what?
Feathers.
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 Yeah, and their legs are covered with what? See if y'all know.
You.
Boy,
How many legs naked?
Scales.
Yeah.
Scales.
They breathe through their what?
Lungs. Make it breathe.
Why is that guess myself?
And do they live eggs? They lay eggs or have live babies?
Legs.
Very good.
Lay eggs.
They lay eggs. Man.
Which we eat sometimes.
Warm but that's true, you know. Y'all eating the pork chicken.
It ain't our fault.
It is your fault.
Hey, everybody gotta
It's
die.
your-
Everybody gotta live, you know.
I tell you, bro, we want to
Oh.
stop it.
No. Be a vegan.
Mr. B.
And you'll be straight.
See, that's
You don't
what
eat eggs?
I don't eat it. No.
You're
You know
serious.
what Mr. B
Nah, you crazy? Nah, Mr. Petit, I think
You don't eat grits and eggs.
know.
No, I don't eat grits and egg. I eat grits and beans.
Oh
Never.
my goodness.
Ew, man.
No.
What's up, invitation crowd?
Mr. B, you don't eat eggs?
Beans.
I don't. Anyway, let's get back.
Grits and egg is hit different in the morning. You don't eat that, man, Mr. T. Come on,
Anyway,
man.
they're warm-blooded
I
or
can't be
cold-blooded?
vegan.
Warm-blooded or cold-blooded?
Warm-blooded. Warm-blooded.
Hey, warm-blooded. Warm-blooded.
They also sit on their eggs, right? So sit
Yeah. That's not.
on eggs
Yes, sir.
until
And then hatch.
they hatch.
Hatch.
They feed and protect their young.
Mm-hmm.
And they have what I really would like to have, but we don't have it unfortunately until we get to heaven.
Wings.
Yeah, they have wings. They have wings and light color wings. So it's easy to break them.
Now what?
Well,
Yeah, it happened.
Well, it depends on. Unless I know you're thinking about chicken, right? And they have bones, you have to crack it.
No spoon.
But yeah,
Are you eating chicken now?
that's the problem.
Learning is just cool, boy.
The problem. All right, good. Now, give me some examples. Name an example. Pink.
The white crown pigeon.
Flamingo.
Flamingo. And then we have
Seagull.
The white crown pigeon.
pigeon. I heard the pigeon. What
Seagull.
eating right now?
Bahama parrot.
Bahama.
Pelicans.
Robin.
Duck.
Pelicans.
You
Pelicans.
never had duck before?
No.
Pelicans.
You know you could eat that?
You could
No.
eat duck.
No.
You could eat Duck.
Yeah.
I heard
Oh, duck
somebody eat it.
tastes good. Duck tastes good. Telling you, duck tastes good.
Duck?
My
No,
mommy,
that even sounds like duck. Boy.
Don't mind
What else
Lionel.
you eat?
I tell you,
Don't mind
What else
Lionel.
you eat, Lionel?
I know, right? Lionel probably eat
duck
octopus.
tastes good.
You trying to eat shark too then?
Like, probably.
Oh, octopus? Okay,
Lionel eat scallops.
There's a Chinese.
Little bush.
That's the
Lionel,
That's the
what else you
minute
eat,
side is
Lionel?
like eat octopus.
You eat oysters too? Alright.
Alright.
Never.
Alright, so
Octopus? Nah.
most wonderful of them all, in my opinion,
Of course.
is the mammals.
Top on the food chain, you know.
Yeah. Body. Now, if y'all don't know this now, covered with what?
Covered with fur.
So your body covered with fur.
Yeah. Oh, fur.
Yeah.
Or fur. It doesn't. Because then for dogs, it's not hairs. Sorry, for wolves and stuff like that, it's they have fur.
Fur.
And for us, it's hair. Right?
Yeah.
We breathe through our what?
Lungs.
Nope.
Lungs.
Long.
Our
Weasley.
young.
This is BT. I was about to say.
Our young is born
Two eggs.
Baby.
Alive.
alive. Do all mammals live on land?
Yeah.
No, dolphins.
No.
No.
For example, a whale, a dolphin, a orca.
But most live on land.
Most of them live on land.
And I know a dolphin will live in water.
But some
In the water.
live.
Yeah.
Okay.
Wait. Wait. Use them.
This is BT. I was feeling in the car right now.
We have a dolphin in the class, man, Mr.
In the
Petit.
class. How do they
That
feed
is-
their young?
Probably. Why?
Feed their young.
That's a good one. All right. Right.
How do you?
That's a good impression, eh, Lionel?
You mean you don't know how they feed their young?
Wait, what?
I know, but it catch you off guard.
Oh, seriously. Feed their young through what?
We all know.
Okay, yeah, yes, no,
You can't say that. That's why they call me off guard.
Let me go back up to the top there. Reptiles, please.
No problem.
That's why I say you call me off guard.
Okay. That's Nathan speaking.
Yes, sir.
Alright. That catch you off guard, eh?
Yeah, I wasn't expecting.
Oh my goodness. And protect them. For what? For years. Alright.
You sure?
Yes. Well,
Yeah.
supposed to.
But
Take, for example, a man with his daughter. I don't care if that woman married, if she's 54. If you hit that woman, she'll go call her daddy.
you're dead.
That's the end of you.
That's the end of you. That's it.
You're dead, but you don't make it.
You gotta go pray after that. I mean, before that.
You better hope she don't get brothers.
Like, what? That's the next.
Everybody's gonna punch him.
That's why I don't like touching. That's why I don't like it.
All her siblings is brothers, is boys. Every last.
Exactly. They'll jump. Very few.
Slap up every
That's it. So, all right. So, man, woman, whale,
dolphin,
bat. Now, bat is an interesting one. You may think a bat is a bird, but
bird.
They look creepy, Mr. BT. I tell you, their face looks so weird.
yeah, wolf, rabbit,
Lion.
tiger.
Technically, did not just say lion.
Yeah, lion.
Elephant.
And then elephant. All right, so. All right, so when we say cold-blooded versus warm-blooded, what do we mean? All right, so that's
Cold-blooded, they like adapt to their surroundings. So, like, if it's cold, their blood could be cold, and when it's hot, their blood could be hot.
Yeah.
And with
Uh-huh.
warm-blooded, the warm-blooded, they keep a consistent temperature. So when it's hot or cold, they'll be in the same temperature.
Very good. Wow.
Yes, sir.
I almost want to say that's Google, but I know that's Kennedy answers. All right.
Say that's good.
No. She answered that from knowledge. All right. So let's make the difference. Kennedy explained it also eloquently. We're gonna put it.
Thank you. Mm-hmm. That's what you get with this study, you know.
You gotta give it a little props.
Animals that change their body temperature with the temperature of the environment rather, of their surroundings, are said to be cold-blooded. So they change their temperature with the temperature of the surroundings. But warm-blooded, like she said, they keep a consistent body temperature. What should our body temperature be?
98.6.
Yeah.
Above 99, you want to check the doctor.
Yeah. You're the scientist, man. Y'all ready for this exam?
That's the they give us is on the exam.
Geo.
You know.
Anyway, someone put 99. Something wrong with you. Like,
regardless of the temperature of the surroundings. Alright, so that's the difference between warm-blooded and cold-blooded.
was it a go up more, please?
No problem. What more? So I look up the bird or what?
All the way more. All right then.
Okay.
Thank you.
So I'm going to state the name of an animal, and I want you to tell me if it's amphibian, fish, bird, or mammal. You ready?
Yeah.
All right. Rabbit.
Mammal.
Come on, man, that's a mammal.
Mammal. You all slow with this. Why else
That's like trying to go working on with them.
No, because I just remember it was first. So that's like, all right.
Turtle.
And crab, amphibian, reptile.
Reptiles, man.
Reptile. Stingray.
Fish.
Amphibian.
Fish. That's
not no amphibian.
Not amphibian. Alligator.
Reptile.
Dolphin.
Mammal.
Fish.
Frog.
Reptile.
Amphibian? What you mixing up? Oh Lord.
This boy set me up.
What an exam this can be.
Snapper.
I'm telling y'all this thing on the
Fish.
Right, fish.
Hummingbird.
Bird.
Exactly. All right, very good. All right. Okay, so next time when we come back, we're gonna discuss the classes for the invertebrates, the animals without backbone. That's where arthropods come in. I saw someone talking about arthropods, but they are not invertebrates. Okay, so they are not vertebrates. Sorry. So that's why we didn't talk to them in this section. All right, so that's it. What's the day for general science? Now we're gonna deal with health science. All right.
Wait, I'm ready.
Say it again.
Never mind.
Oh. All right. So the last time we was in health science, we was talking about the different body systems. Right. We said that we could distinguish how much body systems.
18.
Say it again. how much body systems can we major body systems can we talk about? Major. Which major body systems we could talk about?
You want to know the amount we talked about last class?
No, I want to know. I want to know how much body systems can we distinguish?
10. 10, right? 10. Oh, it's
15,
10.
16, 1.
10.
What did I say?
10.
You say major.
Major. And
We have 10 major systems.
I said 10?
Yes, sir.
All right.
You say, in the notes, you say we can distinguish 10 major systems in the human body.
That's what I said?
And then we start off with the circulatory system.
You sure that's what I said?
Yeah.
Lots.
Whoa.
Your notes, what you write, say that then.
Who was I on?
Mom's teeth.
Yeah.
So, yeah.
Please read our notes, Mom, Mr. Petite, man.
No. Y'all have it right in front of you. Don't think I crazy.
We know that out our head. Like, that was...
Yeah.
Yeah, right. All right, so... The first
Wait.
See that? 10 major systems in the human body.
All right then.
You gotta check for your homework what you make me do.
Yeah, you think you slick, Mom, Mr. Petite.
The homework.
They can't too.
Quiet on that one.
The homework was the endocrine system. I told y'all to tell me. Miss Cooper did it.
Finally. Hold on. This is a oral thing. So I got my notes up in here, in the mind.
In the mind? I didn't say in the mind, Miss Kennedy. I said on paper. Right, Kennedy?
Oh, yeah. Mm-hmm.
Here goes her making up excuses for not doing the work.
All right. Yeah, so we talked about the circulatory system, and that one is responsible for carrying blood throughout the body.
Hormone. Oh, no, that's sorry.
Yeah, circulatory system. And with this blood, it carries with it nutrients, and not only nutrients, but also oxygen. And so that's the function of the circulatory system. Wait, I gonna cut off. I'm coming back in short order.
Okay.
Did you say?
The internet's gonna cut off. I'm coming back in short order. It's soon cut off. I anticipate that.
Want to do a countdown?
I don't know why I didn't turn off yet. It should turn off. Hello? Are we still there?
3, 2.
I don't know why.
Yeah.
We're still there.
Yeah.
Yeah, I can hear you.
Okay, that's strange. Alright, let's keep it until then. It's supposed to now. Alright. Yeah, so.
Yeah.
You still can hear me?
Yes, sir.
Okay.
Yes, sir.
Alright. Wow, I thought it was gonna turn off. It's supposed to. I guess they given me more time. Okay, so then the next one is the digestive system. We use that to. The purpose of the digestive system is to break down food. And very important, so that the body can use the food for nutrients and energy. That's why you eat food. You don't eat food because of how it tastes merely, but you eat food so that you can get nutrients. What nutrients?
The second part?
Go ahead.
No, I'm so sorry. Sorry for disrupting you.
Go ahead. Oh, okay.
No, it's okay.
Oh, I thought you had a question. So the second part, so I end up saying it's the same thing. That's it. But Yeah, so you need to choose foods that will give you the most nutrients. Because that's the purpose of eating. The purpose of eating is not, oh, the food tastes good. No, that's not the major purpose of food. The major purpose
Technically.
of food is to get energy and nutrients. What nutrients you can get from Kit Kat? What nutrients you can get from M&M? What nutrients you can
Protein.
get from
When these get sweet, they sweet.
all you're getting from them stuff is diabetes and extra dose of hypertension.
Yeah, obesity.
Sugar, glucose.
And they have protein?
Never.
I
What?
mean, if it have the nut inside, yeah.
It does have protein, but along it just have an excessive amount of sugar. All right, and you don't want that, right? So you want to choose the foods that will help you to get the best energy, right, and help you to be in the most healthy state. That would be stuff like your
Yeah.
fruits, your vegetables, right? Not your eggs and your bacon and your fat and your stuff, right?
Tastes right.
This is a commercial of how to get in.
But Mr. Petit, what wrong with eggs? So that it has protein.
It's new.
Eggs. You see that yolk? You see that big
Mr.
yellow
Baby
yolk
Chick.
inside there?
Mr. Baby Chick.
That's a bunch of
That don't mean nothing though, Mr. Petit.
Yeah,
That's
people
protein.
eat raw. I don't understand how people eat that crap raw.
Anyway,
Imagine throwing on the blood and eating it. How couldn't
Exactly.
you?
That's just nasty, but I think it was
endocrine system. What's the purpose of endocrine system?
Boy and girl hormones.
Hormones that regulate the body system.
Yes.
yeah,
What
don't
are
you like
hormones?
Chemical messengers, yeah.
Yes, chemical messengers. Okay, Miss Kennedy, you know your stuff.
No, let's begin right here,
no,
right?
no, Mr. BT. She's just looking in a science book right now.
No,
No,
no.
she's the science.
Yeah.
Lionel jealous. Don't be jealous, Lionel. Your time to shine will come.
Bro, what?
All right.
I still have a question from them quiz we used to be having.
Give me some hormones of the give me some components or structures of the endocrine system.
Pancreas,
insulin,
Pineal, whatever thing called.
pancreas.
Pancreas is one. What does the pancreas produce?
Insulin.
insulin.
What's another one? We have the pituitary gland.
Pituitary
gland.
Pituitary gland. Right?
What the? How do you pronounce that?
BT.
I can't remember how to spell that.
Let it out.
ARY.
Come on, Mr. BT. No, Mr. No, Mr. BT.
Mr. B, come on, man.
I don't remember how to spell it. Show me.
Not in the brain?
You could have used Siri.
Say Siri.
I made his mouth, that side.
Mr. BT, you should have blended. Oh, not use Google.
Yeah. All right.
Oh, copy and paste the never.
You could have asked us how to spell it.
I made me talking.
The pineal.
Pineal, yeah, I remember pineal.
What about thyroid gland?
Thyroid, yes. Thyroid.
Pineal gland. Where's that?
Pineal gland, that's still in the brain.
Voice.
That one.
That's some under the gallbladder, like that.
That's somewhere in the brain, I think.
Come on, that's in the brain.
Yeah.
Yeah, the pineal gland is also in the brain. Give me 1 second. 1 second. So, let's continue.
Your friend bored.
Yeah, very bored. Very bored. I don't understand. Man. Like, get a life, honestly, man. Please. Okay. This one, it's a secrete melatonin. Oh, circadian rhythm. So that's circadian rhythm is your sleep pattern. So this gland is the one that tells your body, okay, you sleep.
When you wake up?
When to sleep and when to wake up, yeah.
I don't understand, Mr. BT. People just go sleep like around 12 a.m. or 1 a.m. and wake up like 11 to 1.
Yeah.
In the noon?
You know why?
Yeah.
Why?
Because their circadian rhythm is off. You know what?
But listen,
you know what is make your circadian rhythm off?
What?
Artificial light. So
Now,
see the light inside your room, right?
Yes, sir.
If let's say right currently it's 8:42. So
Right.
all of us more than likely have a light inside our room right now. And
mm-hmm.
so
Yeah.
naturally before there was artificial light, the most you had was a candle, and when the sun set, everything is dark. Everything is dark. So your brain register because your circadian rhythm works based on light. And so when you see um everything going dark, then your body say, okay, time to bring it down to a close now, coming down the end, then to go sleep. Then when your body see light, it say, oh, it's still day. We could still work. So that's where artificial lighting is throw things off. So the light from the sun in the morning supposed to, when you look at that and you feel it, you say, wow, I up now, I awake. That's why if you when you in your house, in your home, and your room dark, it causes you to sleep better. But the only thing is that in the morning, if there's no light coming through your room, you will still think that, boy, I have a lot of time left. And so it'll be harder to wake up. Now,
Yeah.
when you go outside and the sun hits you, then all of a sudden you feel alive. You feel, wow, I alert, because that's the sun. And so the circadian rhythm is regulated by light entering your retina. Now, some people circadian rhythm is off because they spend all night watching TikTok, playing games, playing Fortnite.
Yeah.
Um,
Imagine.
never.
yes, yes,
Look,
yes.
look, Mr. PT, this
And
me. I
then
go to.
You
their
get too
circadian
big.
rhythm is
Yeah.
off. And so what they'll have to do is that they'll have to develop a pattern of sleeping early again. And first they'll have to force themselves to go sleep and then force themselves to wake up. So they get themselves right on right cycle, right on the right side cycle. By right, we supposed to be sleeping the latest 8, 9 o'clock, supposed to, and then wake up
Me.
like five,
All
six
right.
o'clock in the morning, supposed to.
Yeah. Mr.
Um,
PT.
but clearly we don't do that. But that's
Yeah.
the
No,
rhythm
never.
supposed to be. Anyway, go ahead. And the
Mr. PT.
and the pineal gland is the one that helps with that, with the circadian, with the
Excuse me, Mr. PT.
yes sir.
This would be me. I go to sleep like 4 a.m. or 3 a.m. and I still wake up like around 6 o'clock or, yeah, 6 to
Eight.
7 o'clock max.
Wow. Are you human?
Pardon?
Are you human?
I don't know what that is, but
Are you
I don't know.
human? Are you human?
I don't know.
I don't know. I not saying, if he's human.
Onions,
Are you robot or what? Are you
Maybe an alien that's a big baby.
he's Tesla created human robot.
I am not
What?
Elon. I am not Elon Musk test, but Mr.
How
T.
about it?
Elon
Because
Musk.
he
You see
tried to
Elon
call
Musk
me
trying to buy
a,
Twitter?
yeah.
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 He bought 9% of it though.
Off
9.4,
topic.
9.2%.
Yeah, he could do a lot of things with that 9%. Find
Yeah.
so much people. Woo.
All
That
right.
apple is
Off
really
topic.
clean.
The next system is the excretory system.
Are we
Excretory
doing more
system.
tonight?
Yeah, we're doing more. We gotta continue.
These
Um,
10 major systems, right?
the 10 major systems. Yeah, we continue on with the 10 major system.
How much we do so far, Mr. P?
1, 2, 3. So we have 7 more to go. This is responsible
Getting rid of dead cells. I mean,
with
what thing?
in
Dead.
general, for the removal of
Mm,
stuff the body don't need, waste. Give me some example of waste. Stuff the body don't
Chocolate.
need.
Water.
Say it again.
skin.
Water.
Water, yeah, that's urine. Urine is waste.
Oh,
Urea is
Oh,
waste. The body don't need that. Um, what else?
Sweat.
what?
Sweat, yeah, that's still a mixture of water and salt. Um, how about the
Dirt.
gases that come through your mouth and also through your anus. Those gases, your body don't need them, so It expelling them.
Huh?
Say it again. I thought you said something. Okay, organs of excretion would be your skin.
I know what you mean. What you mean?
What you mean? Gases, like when you belch and when you fart, those gases are excreted. Oh boy, y'all just wanted me to say the word. That's what. All right, and then one of the major, you know,
Hello.
excretory organs would be the anus. That's where all the dung, dung, or feces comes out. Your body don't need that. That's why it's important to eat the right things. Because if you don't eat the right things, and you get constipated, and all the waste stay inside
And build up.
and build up, right? That's why you eat foods full of fiber, and animal products have no fiber at all.
Oops.
None, none, absolutely none. So eat your fruits and vegetables, and don't peel off the skin. You need the skin.
You mean don't peel off the skin?
Whenever I eat beans, right, I don't like chew it. I always swallow it.
Why?
Yeah,
Baked beans is the best. I must give you that.
big beans.
Skin, anus.
You
What
say
else?
big beans or big?
I don't understand.
sorry.
Coming from the one who swallows beans, bro.
I know, right? What else? What else is a good?
Mr. BT, I have a question.
But you say the eyes when you cry. I don't know.
I wouldn't say that. I wouldn't say that's excretory organs.
Mr.
Oh,
BT, I have a statement to tell you.
For sure, skin, the anus, the large intestine. But that's more. Yeah, I mean, yeah, we can see that.
Mr. BT, you ever like heard about a story when a girl like she eat a lot of beans and she was in a hospital the next month?
No, I never heard that story.
Uh,
Only Lionel is heavy stuff.
Skin. Oh, and the kidneys. How could we miss it? The kidneys.
I was about to say no. I don't.
The kidneys,
I
because
was
the
about
kidneys
to
for
say kidney.
urine, right? I figured we was
On the lungs.
And the lungs. The lungs. Oh, how could we forget it? The carbon dioxide is a major waste that we need out, right?
Yes.
Move large intestine.
Yes.
I didn't even think about that.
Yeah. So lungs for carbon dioxide.
Kidneys.
Kidneys, yeah. Kidneys. So kidneys would be for urine. The lungs would be for carbon dioxide. The anus would be for dung.
Feces.
The skin would be for sweat.
Sweat.
And then we have the lymphatic system. A lot of people don't know about the lymphatic system.
I heard about it.
Cells, right?
Say it again.
Is that like white blood cells?
It's a no. That would be the
Blood.
Phagocyte.
That's made of blood.
It's a part of it. I mean, phagocytes are a part of it, right? One of the major parts or functions of the lymphatic system is the defense. So it helps the body to fight germs. That's one of the functions.
Infections.
Yeah, germs and infections. That's one of the reasons. But it also is important to maintain the body's fluid balance. That's one of the main component or reasons. So you need in this system you have the lymph, you have the lymph nodes, you have the white blood cells. These are the components of the lymphatic system. So let me show you how the lymphatic system works, or looks really. Lymphatic system. So you have a what's a good one? You see these um bean-shaped looking things. They're all around your body. They're in your neck, right? I don't know if y'all could feel them. You ever feel, you could feel your nodes, if they,
Yeah, on your neck.
on your neck, and in the groin area, you could feel it. Sometimes you could feel it too. In the arms, if depending if your arm is small enough, you could feel it. But the ones that are most conspicuous is the ones that are here and the ones that are in the groin area.
Oh, what they supposed to feel like?
They supposed to feel literally like beans, like little
But your
balls,
lungs.
little stuff like you. If you feel like a little lump.
Little balls in your neck.
Yeah, right. If you can't feel it, that probably mean that you're too big, and um, and
Too fatty.
too yeah, you're too fat,
I can ask my classmate if she could feel it.
right? If you can't feel it, then you're too obese. You need to lose weight.
What's the tea? You could feel yours?
I can feel mine, of course. I huge. I probably can feel all of mine. That's how skinny I is. But yeah, these are the lymph nodes. These lymph nodes are these like the police of your body. So when the germs and stuff are flowing, and they encounter these lymph nodes, the lymph nodes act like police to, contain the germ and actually fight against it. So that's the important part. These actually the tubes that we have um actually keep the body's fluid in proper balance. All right, not the blood, because the circulatory system is for the blood, but in terms of the fluid that comes out of the cells. The lymphatic system is responsible for keeping that fluid in balance. Otherwise, if it get too low, then there'll be a problem. If it get too high, it'll be a problem to the body. So the lymphatic system helps to keep that fluid, that clear fluid, in proper balance. Now, this lymphatic system for the woman, da da da. They usually is green represented. It's nice, but pretty. Okay, so the lymphatic system organs. So we talked about the nodes. Oh, the spleen is a very important one. Um, yeah, the spleen is a very important part of the lymphatic system. We didn't put that. It's lymphatic structure, spleen. All right, and then we have time for more. Let's go to the muscular system. That one works to move the bones, works to move the bones of the body, and move substances through the body. That's the muscular system. So of course the muscles. So what muscles we talking about? The biceps,
Triceps.
Triceps, the quads.
okay, no problem. But who know about the quads, deltoids?
Involuntary, voluntary.
I spelled this wrong. Deltoids. This one. Deltoids is on the shoulder, not on your shoulder, but it's on the back of your shoulder. Like it's not the back of the shoulder, like the bottom of the shoulder. Um, we have let me show you what it is.
Involuntary.
Yeah, involuntary and involuntary. That's true. The cardiac ones.
Tendon.
Okay, so yeah, tendons would also be a part of your muscular system. Tendons.
Ligaments.
Mm,
Tissues can count?
Tissues count. Of course, tissues count. What else we want? We want the cardiac muscles, smooth muscle, all them. So muscles of the heart, muscles of the small intestine, muscles of the of
Skeletal muscles as well.
so yeah. So skeletal muscles, they're the ones that help with,
They're in arms, right?
yeah,
Tendon.
the tendons. The tendons are in the arms, but the tendons are going to be where you have joints. All right. Now, when it comes to the cardiac muscle, they are the ones that are always working. Imagine that. From the day you was born, always working. Stay working.
Non-stop.
Yeah. Start from the heart.
From the heart, right? That's a miracle in itself. Then we have the smooth muscle, which are in the stomach. And throughout.
Like line the stomach.
Yeah, they line the stomach, and they're also throughout
The digestive system.
Right, the alimentary canal. Some of them are involuntary. That means you don't control it. So, when you eat food, you don't control your stomach from moving the food, and churning it, and you don't control it. Just know that you eat the food, and you can't tell your stomach, oh stomach, stop.
Oh, by foot.
Imagine if we did though.
Say it again.
Imagine if we did though.
Right?
Greatest superpower ever.
Secret superpower. But yeah, you can't stop that. Right? Once it go down, once you swallow that, get over. All right. So for homework, I want you to tell me, because I don't want to do another lesson on this. So I think this is overdone. We should move on. The other four I miss. So state the other four. List the other. This homework.
I think you can get this homework tomorrow, Masi.
All right, no problem. At least you can do it. I want to know if Kennedy can do it.
Well, we know the answer to that.
Systems of the body. And their functions.
As well as the organs they include.
And two of the organs or structures associated with these systems. All right, so that's I want you to do the rest. So we did the muscular, lymphatic, excretory, digestive, endocrine, and circulatory. Excuse me.
Will the dean go up, please?
I want you to do the rest. Said go up. You need to go some more?
Yes, sir.
Yes or no?
Yes, sir.
Yeah. Alright, really small.
So we can leave, right?
Alright, so it is 9:01. You are free to leave.
Alright, thank you.
Good night.
Have a good night. See you tomorrow.
Good night.
Take care.
You too. Be safe. Mr. T.
Good night, Mr. T.
Bye.
Good night. Bye.